Ice monsters of antiquity. The prehistoric world holds many mysteries and amazing discoveries. Some of the most impressive evidence of the past are animals that managed to adapt to the harsh conditions of cold. We find their remains in the permafrost of Siberia, Canada, Alaska, and even in the depths of Antarctica. What did they look like? What did they eat, and how were they able to survive in extreme cold temperatures? Below we will talk in detail about the most famous prehistoric cold-loving creatures that lived during the Ice Ages and even earlier. Dinosaurs of Antarctica. During the Jurassic and Cretaceous periods, present-day Antarctica was part of the huge southern supercontinent of Gondwana, which also included Australia, South America, Africa, and India. This landmass shifted toward the South Pole, and Antarctica gradually found itself in the high-latitude zone. Cryolophosaurus. One of the most striking discoveries is Cryolophosaurus, or cold-crested lizard. It was discovered in early Jurassic rocks, about 190 million years ago, in East Antarctica. Cryolophosaurus was a predatory theropod, a relative of the early carnosaurs, about 22 feet long. It had a distinctive bony crest on its head, similar to a coccus or tuft. In the early Jurassic period, Antarctica's climate was not yet as harsh as it is today, but winters could be quite chilly and the long polar night posed certain challenges for the animals. Researchers suggest that Cryolophosaurus, like modern large warm-blooded animals, was able to maintain a relatively high body temperature through metabolism and may have led a semi-nomadic or seasonal lifestyle, changing territories in search of food. Glacialosaurus. Another interesting Antarctic dinosaur is Glacialosaurus, or glacial lizard, a plant-eating sauropodomorph from the same period. Its remains were found alongside the bones of Cryolophosaurus, indicating that the High Jurassic had a fairly diverse dinosaur community, from predators to large herbivores. The polar dinosaurs of Australia. When Australia was still merged with Antarctica, the southern regions of the continent were at fairly high latitudes where, for part of the year, the sun hardly set in summer and hardly rose in winter. This is polar day and polar night. Life in such conditions also required special adaptations. Laernulaer. One of Australia's most famous polar dinosaurs is Laernulaer. It lived in the early Cretaceous period, about 110 million years ago, in what is now the state of Victoria. It was a small, about 4 feet long, ornithopod, probably a bipedal herbivore. Scientists have a hypothesis that Laernulaer had relatively large eyes and long optic nerves, which could indicate a crepuscular or nocturnal lifestyle in polar night conditions. Timimus. Another ornithopod from the same region is Timimus. By the structure of the hind limbs, it is referred to a group close to ornitholomosaurs. Timimus, judging by the finds, was a light, agile animal, probably omnivorous or predominantly herbivorous, able to make fast runs and possibly migrate depending on seasonal climate changes. Dinosaurs of the Arctic. The North Pole of the Mesozoic looked different than it does now. There were no permanent ice sheets there. However, in the Cretaceous, especially near the end of this period, some areas such as Alaska, northern Canada, eastern Siberia, were in a relatively cool climate when looking at average annual temperatures. Paleontologists have found some interesting dinosaur genera there. Pachyrhinosaurus and other horned dinosaurs. Bones of horned dinosaurs, such as Pachyrhinosaurus, which translates to thick nose, have been found in northern Canada and Alaska. These relatively large, up to 22 feet long, herbivorous ceratopsians lived in the late Cretaceous period, about 76 million years ago. Paleontologists have found that many ceratopsians were able to survive cooler climates than expected. This was due in part to their relatively large size, which reduced heat loss. The principle of the bigger the body, the easier it is to retain heat. Edmontosaurus and other platypuses. In Alaska, the remains of Edmontosaurus and the closely related Hadrosaurus were found in Cretaceous sediments. These duck-billed dinosaurs were among the most widespread herbivores of the late Cretaceous. Their herds could migrate long distances in search of better food, allowing them to survive seasonal fluctuations. It is hypothesized that not all populations migrated. Some may have stayed in northern territories and used woody vegetation, ferns, moss, or fallen leaves as winter food. The predatory dinosaur Nanoxaurus, or polar lizard, related to Tyrannosaurus. It has been described from fragmentary remains from northern Alaska. Nanoxaurus was estimated to be approximately 22 feet long and was likely smaller than its famous southern cousin Tyrannosaurus rex. Scientists believe that the reduced size could be one of the adaptations to the colder and less resource-poor Arctic climate. If we talk about cold dinosaurs, it is important to understand that the temperature in the Mesozoic polar regions was still higher than today, and most likely there was no long season of sub-zero temperatures with an icy desert there. However, compared to the tropics, conditions at the poles could be significantly harsher. What techniques allowed dinosaurs to survive? Modern research indicates that many dinosaurs were at least partially warm-blooded. This means that they generated heat through metabolism, similar to birds and mammals. This metabolism helped them maintain a constant body temperature, which is especially valuable in cool conditions. A growing body of evidence suggests that many theropod groups had the rudiments of feathers or down-like structures. Feathers could not only help in thermoregulation, but also serve as a display during mating. In cold climates, the presence of feathers significantly reduced heat loss. There is a version that some species in the polar regions made regular migrations, going south in the coldest months. However, new studies of fossils in northern latitudes suggest that not all dinosaurs migrated. Some may have remained in place, finding food under the snow or feeding on bark, tree shoots, and fallen vegetation. Dinosaurs, especially small and medium-sized predators, were able to stay warm through constant activity, hunting, movement, and group behavior. Herd herbivores also benefited from group life. Animals together could search for food and protect themselves from predators. For a long time, fossil remains of dinosaurs in Antarctica and the high latitudes of the northern hemisphere were almost not discovered, since the territories were partly inaccessible due to eternal ice and extreme conditions. In recent decades, thanks to geological expeditions, new data has emerged, but the gaps in the findings are still significant. Therefore, it cannot be ruled out that in the future we will learn about many new species of polar and cold dinosaurs. Studying cold-loving dinosaurs gives scientists the opportunity to understand the following things. Fossils at high latitudes confirm that the climate there was milder than it is now. This is also further evidence of continental drift, since Antarctic or Arctic dinosaurs lived in an era when the continents were positioned differently. The fact that some theropods could survive this presence in cool zones strengthens the case for partial warm-bloodedness and the presence of feathers as key to understanding the origin and evolution of modern birds. Before moving on to the description of the animals themselves, it is important to understand the conditions under which they lived. Over the past few million years in the history of the Earth, glaciers have repeatedly advanced and retreated. This is what we call ice ages. The most recent global glaciation is considered to be the Pleistocene, which began about 2.5 million years ago and ended about 12,000 years ago. During the peak of glaciation, huge ice sheets covered much of the northern hemisphere, and temperatures in these regions were much lower than they are now. Ice in the upper latitudes and high mountain regions persisted for many thousands of years. Such a harsh environment required incredible endurance and certain adaptations from animals. First of all, this is a thick coat, a layer of subcutaneous fat, and special behavioral strategies. Migration or deep hibernation. Some species even changed their appearance depending on the season. For example, they changed their dark summer coat to white winter coat, as do modern polar hares and Arctic foxes. However, in prehistoric times, the list of such cold specialists was much more extensive and exotic. Surely the first creature that comes to mind when you hear the words Ice Age is the woolly mammoth. These huge relatives of modern elephants were adapted to life in the tundra and steppe. Their body was covered with thick, long hair, and under the skin there was a thick layer of fat that helped retain heat. Mammoths had curved tusks up to 16 feet long and a high fat hump at the withers, which served as an additional source of energy. The woolly mammoth's diet consisted primarily of grasses, mosses, and lichens, which had to be extracted from under the snow using its tusks and sensitive trunk. Mammoths inhabited vast areas of Eurasia and North America. Thanks to the permafrost, not only their bones have been preserved to this day, but also entire carcasses with wool, skin, and sometimes even fresh-looking flesh. Woolly mammoths are thought to have gone extinct about 10,000 to 12,000 years ago when the climate warmed and much of their native range disappeared. Hunting by ancient people played an additional role in their disappearance. Woolly rhinoceros or Coelodonta antiquitatis. Another symbol of the Arctic fauna of the Ice Age is the woolly rhinoceros. It was much more compact than modern rhinoceroses, but had a thicker and warmer coat. The main feature of the woolly rhinoceros was its large front horn, up to 3 feet or more long, which the animal presumably used to heat through the snow in search of herbaceous plants. Like mammoths, woolly rhinoceroses inhabited vast areas of Eurasia. Their bones and carcasses have been found in Siberia, Europe, and Alaska. The disappearance of these animals coincided with the extinction of mammoths and other large mammals of the Ice Age. Saber-toothed cats, Smilodon and Homotherium. Although often called saber-toothed tigers, saber-toothed cats are a distinct branch of felids and not the direct ancestors of modern lions or tigers. There are several genera of saber-toothed cats, among which the most famous are Smilodon, mainly in America, and Homotherium in Eurasia and Africa. Smilodon had enormous fangs that could exceed 15 centimeters in length. But it is important to understand that not all saber-toothed cats were inhabitants of exclusively cold regions. Some lived in warmer climates. However, Homotherium serum, which lived in North America, including Alaska, and northern Eurasia, thrived in harsh conditions. These large predators hunted herbivores such as horses, bison, woolly rhinoceroses, and even young mammoths. Saber-toothed cats were specialized hunters, and their long fangs and strong forelimbs made it possible to effectively cope with large prey. They disappeared towards the end of the Pleistocene, probably due to a decrease in available food and climate change. Cave bear or Ursus spelaeus. Cave bears lived in Europe and Asia during the last ice age. They were larger than modern brown bears, and their weight could reach 500 to 600 kilograms or more. They received the name cave due to the fact that their bones were often found in deep caves where animals spent hibernation or died during it. According to a number of studies, cave bears were predominantly herbivores. Their diet consisted of nuts, berries, grass, and mosses. However, with a lack of plant food, they probably did not disdain carrion. Over time, the number of cave bears decreased. Firstly, the areas of cold meadows and forest tundra were reduced, and secondly, people expanded their habitat, and bear caves often became convenient shelters for our ancestors. The cave bear finally became extinct about 27,000 years ago. Bighorn deer or Megaloceros giganteus. It is sometimes called the Irish elk, although in reality it is a large species of deer, having huge antlers up to 11 feet in span. At the same time, the bighorn deer weighed about 500 to 700 kilograms. These animals lived in the vast expanses of Eurasia, including cold and temperate zones. The large horns of males served not only for protection and fighting for females, but also as a symbol of status and attractiveness during mating. Although big-antlered deer are sometimes referred to as glacial megafauna, they actually survived the peak of the last deer changes and continued to exist even after warming. However, rapid changes in ecosystems and, Probably, hunting from outside led to a decline in the population. The last representatives of this species disappeared approximately 7,000 to 8,000 years ago. The Mesozoic era covers 3 periods: Triassic, Jurassic, and Cretaceous. At this time, dinosaurs dominated the planet and the climate was generally warm and humid. But this does not mean that there were no regions with relatively cool climates. In addition to mammoths and rhinoceroses, bison, Bison priscus, and musk oxen, ovobovini, lived in the vast glacial tundra steppe. The modern musk ox, Ovobos moschatus, which is found in Greenland and northern Canada, has survived to this day. These animals have thick fur and a thick layer of subcutaneous fat, allowing them to withstand extremely low temperatures. Fossil evidence suggests that the ancestors of musk oxen also inhabited Siberia and Alaska. As for bison, there were several species and subspecies adapted to life in cold areas. Large herds of these herbivores grazed in North America and Eurasia until the end of the last ice age. Man played his role here too. Bison hunting was an important source of food and resources for Paleolithic hunters. Cave lions, Panthera spelaea. Although these predators did not always live in caves, they were quite common inhabitants of the steppes and forest steppes of Eurasia. Cave lions were larger than modern African lions and, according to some sources, had less or no manes, which may be due to the cold climate and adaptations to hunting in such conditions. Most known giant sloths, Megatheridae, lived in the Americas, mostly in the warmer latitudes of South America. However, the genus Nothrotheriops, including Nothrotheriops shastensis, has also been found in relatively high latitudes of North America, up to the southwestern United States. Although the climate there was not as harsh as Alaska, winters could still be quite cold, especially on the high plateaus. Adaptations to cold and giant sloths were less pronounced than in northern mammals, so they cannot be considered fully Arctic. However, they are an example of how many different forms could disperse and move into cooler zones if the conditions were right. There is plenty of vegetation and relatively mild winters. To survive in extremely low temperatures, prehistoric animals developed various adaptations. Woolly mammoths, rhinoceroses, and many other mammals had 2 layers of fur, guard hairs, longer hairs, and a short, downy undercoat. This multi-layering made it possible to retain heat. The thick layer of fat helped maintain body temperature and served as an energy reserve during periods when food was not available. We see a similar strategy in modern seals, whales, and bears. Some northern forms have relatively shorter ears, tails, and limbs to reduce heat loss. This principle, Allen's rule, was also relevant for many ancient animals, although such details are more difficult to reconstruct from fossil remains. Some species could migrate to less cold areas during harsh winters, while others could go into deep hibernation. The massive formation of bone deposits of cave bears and grottos suggests that they spent a significant part of the cold period in hibernation. Survival in the tundra steppe zone of the Ice Age required the ability to obtain food from under the snow. Mammoths and rhinoceroses had long tusks and horns. Bison had powerful forelimbs with which they shoveled snow. Saber-toothed cats had special tactics for hunting large herbivores that remained on the open plains. The end of the last ice age led to climate warming, rising sea levels, and changing landscapes. The vast tundra steppes that were home to mammoths, woolly rhinoceroses, and other species have shrunk. Forested areas moved north and grassy areas began to disappear. Animals that were adapted specifically to the open glacial landscape faced a lack of food and habitat. In addition, people played a significant role. It is believed that the activities of Paleolithic hunters contributed to the decline in populations of large mammals. The remains of mammoths, bison, and rhinoceroses are discovered along with stone tools. The uncontrolled hunting was likely the final blow for the already vulnerable, cold-adapted animals. A combination of climate change and human influence led to the mass extinction of large Ice Age animals. However, many of their relatives live to this day. Elephants are distant descendants of mammoths, rhinoceroses are close cousins of woolly rhinoceroses, lions continue to reign in Africa, bears inhabit vast areas of the northern hemisphere. And the muskox remains one of the few species that survived the Pleistocene almost unchanged and still lives in the harsh expanses of the Arctic. The study of these animals gives us valuable information about the mechanisms of evolution and survival in extreme conditions. Understanding how fauna respond to climate change helps predict what might happen to modern animals under conditions of global warming or, conversely, potential future cooling. In addition, discovering carcasses and skeletons in permafrost is one of the key ways to learn about the genetic and physiological appearance of ancient creatures. Modern technology allows us to sequence their DNA, and scientists are increasingly discussing I wonder if it is possible to one day revive some extinct species. This is the so-called Mammoth De-Extinction Project. Despite the fantastic nature of such ideas, serious scientific institutes are already showing interest in them. One way or another, the legacy of the Ice Age and its cold-loving inhabitants continues to inspire scientists and enthusiasts around the world. And even if we don't see mammoths in person, our understanding of the past gives us the opportunity to treat the present with care and anticipate consequences for the future. The story of animals that lived in extreme cold is a story of perseverance and adaptation. Woolly mammoths, rhinoceroses, saber-toothed cats, cave bears and lions, bighorn deer and many others, all of them, each in their own way, managed to adapt to the realities of the ice ages. However, when ecosystems began to change and humans came into play, many of these species were pushed to the brink of survival and eventually became extinct. Their disappearance reminds us of the fragility of wildlife and its dependence on climate. If you watched this video, give it a thumbs up and leave comments. Subscribe to the channel right now. Click the bell so you don't miss new and interesting videos from the channel Real Unreal.